Look up at the Kuala Lumpur skyline right now, and you'll see something that changed architecture forever. The Petronas Twin Towers aren't just Malaysia's pride. They're the blueprint Western architects have been secretly studying for 27 years. And what they're discovering is blowing their minds. Before we dive deep into this architectural revolution, if you're proud to be Malaysian and you want to see more content celebrating our achievements on the world stage, hit that subscribe button. Because we're about to uncover stories that remind us why Malaysia truly boleh. Your support keeps these stories coming. Assalamu alaikum. When Cesar Pelli stood in downtown Kuala Lumpur in 1991, he faced an impossible challenge. Design the world's tallest building in a country that had never built anything over 40 stories. Most Western architects would have imported their standard glass box design and called it a day. Pelli did something radical. He looked at Islamic geometry, at Malaysian culture, at the tropical climate we live with every single day. And he created something the West had never seen before. Here's what nobody tells you. The Petronas Towers weren't just tall. They solved problems Western skyscrapers are still struggling with today. Think about every modern skyscraper you've seen in New York or London. Square, rectangular, simple geometric shapes. Why? Because they're easy to build and easy to design. But Pelli chose an 8-pointed star based on Islamic patterns. Each tower's floor plan uses 2 interlocking squares rotated 45 degrees. Sounds complicated, right? It is. But here's the thing. That complex shape does something brilliant. Every single office space in the Petronas Towers is within 9 meters of a window. 9 meters. In a building that wide, that's insane. Compare that to the Sears Tower in Chicago. Some offices are 15 meters from natural light. Workers there need artificial lighting all day. Higher electricity bills. Lower employee satisfaction. The Harvard Business Review published a study in 2018 showing that workers near windows are 15% more productive. Pelli knew this in 1991. Western architects are now copying this exact principle. The new Bloomberg headquarters in London, completed in 2017, uses a similar concept. Not the Islamic geometry, but the obsession with natural light penetration. Norman Foster literally cited the Petronas Towers as inspiration during an interview with Architectural Digest. He said, and I quote, "What Pelli achieved in Kuala Lumpur made us rethink how we approach office tower cores, but the genius goes deeper. Way deeper. Walk into any glass skyscraper in Europe during summer. It's an oven. Those beautiful glass facades? They trap heat like a greenhouse. Air conditioning costs go through the roof. The Willis Tower in Chicago spends over $10 million yearly just on cooling. Now walk into the Petronas Towers during our hottest months. It's comfortable. Not just because of air conditioning, because of design. Pelli used a double-layer facade system. The outer layer is stainless steel and glass. The inner layer is concrete and glass. There's an air gap between them. That gap acts like insulation. Hot Malaysian sun hits the outer layer. Heat dissipates in the gap before reaching the inner layer. The building stays cooler naturally. Energy costs drop by 30% compared to standard glass towers. Guess what every major architectural firm is doing now? The Shard in London uses a similar double-skin facade. So does the Shanghai Tower. The Lotte World Tower in Seoul. One World Trade Center in New York has a modified version. All built after 2010. All using technology Pelli pioneered in Kuala Lumpur in the 1990s. But here's where it gets really interesting. Malaysia sits on an earthquake zone. Not a major one, but tremors happen. We also get monsoon typhoons occasionally. And we're near the equator, so thermal expansion is extreme. A building that tall needs to move. It needs to breathe. Western architecture traditionally used rigid steel frames. Fight the movement. Resist the force. Pelli said no, let it move. The Petronas Towers use a hybrid structural system. High-strength reinforced concrete core. Steel and concrete composite floors. This combination gives the building flexibility. During high winds, the towers can sway up to 90 centimeters at the top. You won't feel it if you're inside, but it's moving. That movement prevents structural damage. It's like how bamboo bends in storms while rigid trees snap. This hybrid system was controversial. American engineers told Pelli it wouldn't work. Concrete can't go that high, they said. Steel is the only option for super tall buildings, they insisted. Thornton Tomasetti, the structural engineering firm, had to run thousands of computer simulations to prove the concept. Now, the Burj Khalifa uses a reinforced concrete core. So does the Shanghai Tower, the Ping An Finance Center. Concrete is now the preferred material for super tall buildings worldwide because of what Malaysia proved possible. And we haven't even talked about the Sky Bridge yet. That sky bridge connecting the two towers at levels 41 and 42 isn't just for show. It's the world's highest two-story bridge between buildings. But here's what makes it genius. It's not rigidly connected. The bridge sits on sliding joints. When the towers sway in wind, the bridge moves independently. It slides back and forth on ball bearings. This prevents stress concentration. If the bridge was fixed, the tower's movement would eventually crack it apart. Pelli designed it to dance with the towers. Engineers from Arup, one of the world's leading structural firms, studied this sky bridge design for 3 years after the Petronas Towers opened. They published a technical paper in 2001 calling it a paradigm shift in connected tower design. Now look at the Marina Bay Sands in Singapore. 3 towers connected by a massive sky park on top. Uses the same sliding joint technology. Inspired directly by Kuala Lumpur. Remember what I said about Malaysian context? Here's the cultural element that changed everything. Pelli integrated Islamic geometric patterns throughout the entire building. Not just decoratively, structurally. The floor plan's 8-pointed star represents Rub el-Hizb, a symbol in Islamic art meaning unity and harmony. The number of floors, 88, is considered lucky in Chinese culture. The towers were topped out during an auspicious date calculated by both Islamic and Chinese calendars. This wasn't just architecture. It was cultural synthesis. Western firms are now hiring cultural consultants for major projects. Before Petronas, skyscrapers looked the same everywhere. New York, Hong Kong, Frankfurt. Interchangeable glass boxes. After Petronas, architects realized buildings could reflect local identity while being cutting-edge modern. The Taipei 101 uses bamboo-inspired sections and feng shui principles. The Burj Khalifa incorporates Islamic geometric patterns in its Y-shaped floor plan. Cultural architecture became valuable, not outdated. But the real revolution is happening in sustainability. The Petronas Towers collect rainwater on the roof. That water goes through filtration systems and gets used for landscaping and toilet flushing. In a tropical climate where it rains 200 days a year, this saves millions of liters of treated water annually. The building recycles 70% of its waste. The HVAC system uses demand-controlled ventilation, adjusting airflow based on occupancy sensors. This was environmental technology in 1998. Most Western skyscrapers didn't adopt these systems until the 2010s, when green building certifications became mandatory. Today's LEED Platinum buildings and BREEAM Outstanding certifications? They're using checklists that the Petronas Towers basically invented. Natural light optimization. Rainwater harvesting. Waste recycling. Energy-efficient facades. Thornton Tomasetti's senior partner admitted in a 2019 interview that the Petronas project wrote the playbook for sustainable super-tall design. Let's talk about construction speed. The Petronas Towers took 6 years to complete. That's fast for buildings that tall. How? Pelli used an innovative construction method. Both towers were built simultaneously by different contractors. Tower 1 by a Japanese consortium led by Hazama Corporation. Tower 2 by Samsung Engineering and Construction from South Korea. They competed. Friendly competition, but still competition. This drove efficiency. Tower 2 actually topped out first, finished 3 weeks ahead of Tower 1. Major construction firms worldwide now use competitive parallel construction for twin tower projects. The Nanjing Greenland Financial Complex in China. The JW Marriott Marquis in Dubai. The Time Warner Center in New York during its renovation. All borrowed this strategy from Kuala Lumpur's approach. And here's something that'll surprise you. The Petronas Towers are still the world's tallest twin towers. 27 years later. Buildings have gone taller. The Burj Khalifa. The Shanghai Tower. But nobody's built taller twins. Why? Because Pelli's design is so efficient, so perfectly balanced between height and stability, that improving on it is nearly impossible with current technology. Engineers have tried. Several proposed projects in China and the Middle East aimed to build taller twins. All abandoned or redesigned as single towers because the engineering challenges were too expensive to solve. This brings us full circle to why Western architects are still studying Kuala Lumpur. The Council on Tall Buildings and Urban Habitat, the official organization that certifies building heights, ranks the Petronas Towers among the 20 most influential skyscrapers ever built. Not just in Asia. Globally. The American Institute of Architects included it in their Buildings That Changed Architecture exhibition in 2015. Architecture students at MIT, Yale, and Cambridge study the Petronas Towers in their core curriculum. Not as a case study in Malaysian development, as a case study in revolutionary design. Malaysian engineers worked alongside international teams throughout construction. We learned. We adapted. We innovated. Today, Malaysian firms like Binapuri and IJM are designing skyscrapers across Southeast Asia, using techniques refined on the Petronas project. We're not just copying anymore. We're leading. So the next time you're stuck in traffic on Jalan Ampang and you see those towers gleaming in the distance, remember this. That's not just a pretty building. That's a 452-meter-tall middle finger to everyone who said developing countries couldn't innovate. That's proof that respecting culture, embracing climate challenges, and thinking differently creates something timeless. Western architects aren't copying Kuala Lumpur because they lack ideas. They're copying because Cesar Pelli, working with Malaysian vision and ambition, created something so fundamentally right that it became the template. 27 years of architectural evolution later, and the principles born in that Kuala Lumpur construction site still define how we build toward the sky. If this changed how you see those towers, hit that like button. Subscribe for more stories about Malaysian achievements that shaped the world. Drop a comment telling me what Malaysian landmark we should explore next. Because our country has more secrets worth uncovering than you realize. And I'm just getting started.